So now we're going to talk about a continuation of quadratics, finding the vertex and roots of a quadratic. So this specifically entails if you have an equation. If you have a graph, it should be pretty straightforward, especially with something like Desmos to identify the vertex and the roots. So the quadratic formula, which hopefully you remember, is something that we're going to use extensively. Now, I prefer this separated, this split version. Notice that we have two terms here. This ends up being the axis of symmetry of the quadratic. This is kind of important and incredibly useful because if this is the axis of symmetry, it means that the plus or minus, this is the distance of the roots from the axis of symmetry. This is a little less important, but that's how the quadratic formula works. It works by a method of completing the square, which, if you remember this, that is particularly this negative opposite b over 2a, means you never have to actually complete the square again. I know that's bad news or good news, depending on how you look at it. This may be the other form. These are equivalent. The only difference is I've split this up so you have these two terms separate. Opposite b over 2a is your friend. So here's what I'm talking about. In general, finding the vertex. Now we're going to assume that we're looking at something that is in standard polynomial form, so y equals ax squared plus bx plus c. So for instance, y equals 2x squared plus 7x minus 4. Now, finding the vertex, right, involves identifying what's the a and the b and the c. So that's the a, that's the b, that's the c. Positive 2, positive 7. So to find the vertex, right, all you need to do is figure out what the axis of symmetry is. So it would be opposite b over 2a, which would be negative 7/4. Or if you don't like that, negative 1.75. Now, this means that the coordinate for the vertex, half of it at least, has been figured out. All that remains then is to go ahead and plug in the 1.75, which I'm going to do in a tedious manner here using Desmos, right? To plug in the 1.75 into the equation, because with every x there comes a y, right? So what we do is we do 2 times 1.75 squared plus 7 times 1.75 minus 4, and I'm getting 14.375. So 14.375. Please bear in mind that when I plug the x in to this equation, so y equals 2 times negative 1.75 squared plus 7 times negative 1.75 minus 4, that is where I got my 14, my sloppy 14, so let's fix that, my 14.375, right? So that's the vertex. Now please bear in mind the vertex is a coordinate, that is an x and y value. You should be able to identify too if the vertex is a min or a max. Now, because a is greater than 0, that is not negative, that is lead coefficient is positive, it means the graph opens up, as you full well know, which means that this is a relative minimum. So for the vertex of this, we'd say there's a relative, well, I'll spell it out for you, quite literally. Minimum at negative 1.75, 14.375. Okay, that would be it, finding the vertex. Now finding the roots, we're going to have to move to a different page for that, but let's say, I'll give you two examples. One is something that you can factor, which makes it nice and easy. So let's say we had something, so this is finding roots. There's two ways to go. So the first thing you probably want to do, so let's say we have x squared plus 7x plus 12, right? Now, as a double check, if you're not sure, you'll remember that at some point, minus, there's the discriminant of that is there's this portion of the quadratic formula. This is part of finding the distance from the vertex, and there's three possibilities. This could be equal to 0, which is possible, right? B squared minus 4ac could be positive, which is also possible, meaning we can take the square root, or it could be negative. Now, we call this the discriminant, not because it's discriminating, but because it discriminates between different options. So it's kind of a awkward term at best, but this would mean that there's one solution, aka one root, right? This, because we get two numbers when we take the square root here, because we're doing the plus or minus part, we get one number, but we're adding and subtracting it, would mean two solutions or roots. And in this case, because we're talking about, so this has no real solutions. If you think carefully, you know that you can take the square root of a negative and get an imaginary number, which means it is possible to find roots that are imaginary or complex numbers, but we're not going to concern ourselves with that quite yet. Now in this case, if I'm looking at the discriminant, 7 squared minus 4 times 1, which is a, times c, which is 12. I know that this is 49. 4 times 1 times 12 is 48. So that's 1, which means I'm going to have, that's greater than 0, so I'm going to have two solutions. Now it is factorable. Now remember, factoring, and especially in the case where we can get x so it has a no lead coefficient, is looking for two numbers that multiply to get 12, like 1 and 12, or 3 and 4, or 2 and 6, right? So one of these pairs works out such that when you combine them by adding or subtracting, we get a 7. So in this case, the 3 and the 4 work out kind of nicely. 1 plus 12 or 1 minus 12 doesn't work. 3 and 4 do. Remember, multiplying get a positive, which means either they're both negative or they're both positive, but they're adding to get a positive, which leads us to this. This is then the factor form, which means that the roots, aka the zeros, are when x plus 3 and x plus 4 are equal to 0, which are at -3 and -4. Remember, we're looking at when does x plus 3 equal to 0, that is when the y value is 0, and when is x plus 4 equal to 0, that is when is the y value 0, and when you solve this, this becomes x equals -3, subtract 3 from both sides. So if I put -3 in, this whole thing goes to 0, meaning it's a root or 0, right? That's why roots are also called zeros, also solutions. And same thing happens when I plug -4 in. Okay? So if you can factor it, that can save you a lot of grief, because factoring is a pretty straightforward process. If, however, you're not too good with factoring, or you're not sure, there is a guaranteed way, and that's a quadratic formula. So you'd still want to, so let's try something. Let's see, if f of x equals 3x squared plus 2x minus 5. This doesn't look immediately factorable. Just to make sure I don't embarrass myself, I'm going to do 2 squared minus 4 times 3 times, now watch this, this has got to be careful here, -5. So this is the same as saying 4 minus a negative will be plus, 12 times 5 is 60, 64. This means that there are two solutions, right? Okay. Now, someone, namely me, has picked some really interesting numbers. In any event, we know that then this is a, this is b, and this is c, that's a -5. So then we can use the quadratic formula. So opposite b over 2 times a plus or minus the square root of, hey wait, this is going to look familiar, b squared minus 4 times a times c. So if it works out where you have to end up using the quadratic formula anyway, using the discriminant saves you that step, right? Now, -2, those twos will cancel, so this is -1/3. I'm going to leave as a fraction. I know that's annoying to some people, but tough, especially because it's third, so it'd be 0.3 repeating. Try to avoid that if possible. So this would be the square root of, well, we already know that this ends up working out to be 64, so why don't we just go there, right? Now, this is a distance, so when we take the square root, we're just going to get the positive, but remember, we're adding and subtracting anyway. So this is going to be -1/3. Plus or minus, square root of 64, by the way, is not 32. It is 8 over 6. Ooh, check this out. -1/3 plus or minus, that's a reducible fraction. And the reason it's good to reduce fractions in this particular case is because when I take -1/3 plus 4/3, I get So remember, this gets us two answers. We have to add and subtract. When we add these, we get 3/3, aka 1. That's one of our roots, right? So x equals 1 is one of the roots. And I don't think we're going to get an integer for the next one, but when I take negative 1/3 minus 4/3, I get a negative. Negative 1 minus 4 is negative 5/3. I'm just going to leave that as negative 5/3. The reason is that is much more, you guessed it, accurate. Okay. So it turns out this was factorable. As a matter of fact, in fact, if you were to look at that x minus 1, because 1 is a solution, right? Now, with how this works out, and we'll talk about rational zeros here in a little bit, but if you think carefully, if you kind of work backwards, this is going to be 3x plus 5. If you were to distribute this, you would actually get this right here. Okay? If you don't believe me, try it. But as long as you understand how to use the quadratic formula, we're good. Okay? This concludes, I'm pretty sure, we'll do some examples next, concludes how to find the vertex and roots of quadratics.